In section 3.2, we're going to move from talking about measures of center, mean, median, and mode, to measures of spread. Okay, so in other words, how spread out is the data. So the big picture viewpoint, again, that we're going to be taking here is that measures of center, or averages, if you will, don't tell the whole story. Okay, how spread out the data is tells us something too. Okay, so as you can see in the class 1 and class 2 that I jotted down there at the side, the mean, the average for both classes is a 70. Okay, but very different in terms of the results, right? One class very consistent as a 70. So as a teacher, if I saw that, I would know specifically what I need to work on. You know, they're all achieving, but I need to do something to bump that up. In the other class, it kind of looks like I've got people who know what they're doing, and then people who are, you know, maybe completely lost, or maybe they don't come to class or whatever. That's a whole different situation that I have to deal with. So it's not just about the average. Other measures will give us some really important information as well. So we can't just look at a mean and move on. All right, so let's take an example here. We've got our sugar, grams of sugar. Again, this is something that we've already talked about. So first thing, does the data represent a population or a sample? So remember here it says these are all of its foods. And so this is going to represent a population because it's about everything. On a previous page, we found that the mean was 6.4 grams of sugar. So the symbol for the population mean is mu. And then for the range of this data, the range is defined as the highest value minus the lowest value. Okay, that's what range is. Or maximum minus minimum, whatever you want. All right, so looking, our highest value is 27 grams of sugar. Our lowest is 0. That was our mode too, if you remember. And so our range of data is 27 grams of sugar. That's one possible measure of spread of the data, okay, the range. The other one that we're going to be using a lot is standard deviation. Now, this is something that students, especially when we're in person and I can see their faces, I usually will say, so how many of you have heard of standard deviation? And everybody in the room will raise their hand. And then when I say, how many of you can explain what standard deviation means, there's usually only 2 or 3 hands that still remain up. And even when I then say, can you explain it to me, they have a hard time doing so. All right. So if you're like, I'm just not so sure, that makes you 100% normal. All right. It takes a while to grab this. And so what I want to do is I want to kind of give you an idea. I'm not going to give you this fancy mathematical definition because it's not going to do anybody any good. Okay, the mathematical definition is a fancy formula. I'm going to give you the concept, right? Trying to speak English to you. So what standard deviation does is this measures the average distance that's the deviation part. The average distance is the deviation. The data is from the mean. Okay, so how closely do all of those different data values match the mean? Okay, if those data values pretty well match the mean, they're pretty close, you're going to have a small standard deviation, okay? Because the distance from the mean isn't very large. However, if you have a whole wide range of values, okay, maybe test scores that range from 0 all the way up to 100, your standard deviation is going to be larger because 0 away from the mean of, say, 70 is way different than 68 from the mean of 70. If you had a bunch of scores between, say, 60 and 80 and the mean was 70, that's a smaller standard deviation. The values are all closer to 70 than values from 0 to 100 would be that still have a mean of 70. Okay, there's a lot wider range. Another term you'll hear me use is consistent. How consistent is the data? If the data is really consistent, you'll have a small standard deviation. If the data is really inconsistent, okay, values kind of, again, up and down and all over a little bit everywhere, then you would have a larger standard deviation. And I hope that gives you a little bit of a guideline as to what it means. Just again, this like conceptual idea in your head.